In the fishery sciences, it's important to determine the length of a fish as a function of its age, right? Because when they pull the fish out of the water, they should be able to say about how old the fish is so that they know if it's a keeper or you got to throw it back. Same thing with like when you're hunting other animals. I don't know about hunting, but probably turkey or deer or something. They have to be a certain size to keep them or shoot at them. I don't know. So one common approach uses a decreasing exponential function of age to describe the remaining growth, and they're studying the North Sea sole, which is like a white fish, kind of like haddock or cod, I think. So the maximum length that a sole could be is 14.8 inches long. So like the oldest fish, the oldest sole is probably that long. So when you catch the fish, you're going to measure its length on your scale, right? So based on its length, you know the remaining growth that it will still have in its lifetime. And so they're using the age as a function of remaining growth. So our first step is to complete the table just by filling in the remaining growth column. We're going to do this column at the end, predicted by our formula. So don't fill anything in over here first. So if the sum has to be 14.8, you're going to subtract the length from 14.8. So you just do 14.8 minus 7.5, right? So the next one should be 7.3. So that sole could still grow 7.3 inches. So go ahead and fill in that table. So this is the column so that this plus this should equal 14.8 each time. Hopefully I added them all right. Okay, so it says find the exponential function, so they're telling you what type of regression to do, that relates the remaining growth, so this is the remaining growth column, to age. So this is going to be our list 1, and this is going to be our list 2 in our stat edit on our calculator. So stat edit. So we're going to enter list 1 and list 2 and do an exponential regression. What? Stat calculate. We want to do the exponential regression. So let's see if we have the same one to show up here. Is this what you guys got? 4.8. Is that right? Times 1.17. I don't know. Stat edit. Oh, whoops, remaining growth. I entered the wrong set of data. 1 second. 11.1, 7.3, 4.8, 3.3, 2.1, 1.3.8, 0.4, zoom 9. Okay, oh, there we go. Is that what yours looks like? I have something in my y equals menu I'm just going to get rid of. Y equals, clear that out. All right, so it did look like an exponential growth or decay graph, right? So that was the age and the remaining growth. It makes sense that the older the fish gets, the less they have to grow. Does anyone need help getting that to show up? So now when we do stat calculate exponential regression, did you get 19.11? So y equals 19.11 times 0.63 to the x, if I round. So that was column 1 and column 3, relating the age to the remaining growth. Now, if you are fishing, you don't want to calculate the remaining growth. You just want to measure your fish and figure out how old the fish is, right? So on the back page, we are going to graph the length of the fish with the age on the x-axis. So on the back page, we're going to do this as x and this as y. And what we're going to try to do is use this equation, transforming it to get what we really want. We really want to know if I do the length of the fish, how old is the fish? But in order to get this function, you need to use these two columns, and I'll show you why. So we're going to graph time on the x-axis, so the age of the fish, and the length of the fish. And this is experimental data, so it's not going to be perfect. But what do we have to go up to? 14? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so you can count by 1 inch on the y-axis. So this is the length in inches. So you're going to plot column 1 and column 2 on the back by hand, and then we're going to see how this model can be transformed. So see, step 3 is going to be find a formula that relates the length of the sole to its age. So we're going to use this equation to figure that out. So right now I'm plotting like 1, 3.7. So 1, 3.7, 2, whatever it was, 2, 7.5. I'm going to put the red is the data that I just graphed on the back page, right? Is that what your data looks like? So when I originally had put this up by accident, this to me does not look like a typical exponential function, right? It's been reflected. So what we need to do is we need to figure out what transformation rules will take this blue curve and get it on top of this red curve, because the curve is the same shape, it's just been transformed. So what is one of the transformations that has happened when I'm doing, this is when it was the column 3 remaining growth, and then red is what I just plotted on the back, relating the actual length of the fish. So how can I transform my equation? My equation was that 19.11 equation. So they want you to find a formula that relates the length to its age. Look at your graph and think about the graphs of the other exponential graphs you've seen. Don't compute an additional regression. Use your transformation rules and the equation from example 2. So how do I go from this to this? Which way is it being reflected? Over the x-axis type reflection. So what would I do to change this equation? All right, so let's see what happens if I put a negative in front of it. Negative 1911 times 0.63 to the x. So we're kind of just thinking about this together. But negative 1911 times 0.63 to the x. I'm just going to change my window because I know that you're not going to be able to see it. So there's my original blue curve. That's the one I'm trying to transform. When I flip it, I'm way down there, right? Because I just flipped the blue curve over the x-axis. So what also needs to happen to the red line to meet the dots? How do we get the red line to meet the dots? Do I need to shift it up, down, left, or right, or stretch it? Up. How much do you think I need to shift it up? Think about this problem and what the horizontal asymptote should be. What should the length of the fish be approaching over time? How much do you think I need to add to move this up to here so that they're going to overlap? Right now, what is this red graph approaching? It's approaching 0. What do I really want the red dots to approach in this application problem? I want it to approach 14.8. So if I transform this up 14.8, then I should have it. So on my computer, on my ship, if I use this function, then whatever I pull out of the water, I measure it, it'll tell me the age of the fish. So I really need to add 14.8. So yeah, this was this blue set of dots. This was the remaining growth of the fish. So the red is actually the actual length of the fish related to its age, right? Because the longer the fish, the older the fish is. So your calculator is unable to figure out this red equation because it can't figure out exponential flips and all that stuff. So that's why the blue graph looks exponential. So your calculator will do a good job with this blue exponential graph. And then what we did is we flipped the blue graph over and we shifted it up. So now our model for part 4 is right here. It's basically the exact equation we found, but it's flipped over and shifted up 14.8. So they want you to use this circled equation and say, all right, if I get a 3.7-inch fish, what does the formula say the age of my fish is? Right? Find a formula relating the length of the sole to its age. Oh, no. So we're going to plug in the age, right? X is age. So we're going to plug in X as 1, and we're going to see what our formula gives us, right? Because these were all experimental datas over here for the fish. So we want to see how close our formula really is. So in my y equals menu, if I put in that negative 911 times 0.63 to the x plus 14.8, and I go to my table for 1, 2, 3, 4, 5, 6, 7, 8, it'll tell me what length I should have. So for example, if you're doing it right, your first answer should be 2.8 if I rounded it. And 2.8 is a little bit different than 3.7. Then I get 7.2, which is a little bit closer to 7.5. Right? I'm comparing the length of the fish. These should be kind of the same. So see what the rest of the values that it gives you. It wasn't exactly the same, but